This morning, so we appreciate the time and effort coming out, and we hope you guys enjoyed the lunch and learn lunch. Basically, we're going to have the lunch or the lecture first, and then after that we'll have lunch. So during the lunchtime, we want to use that as a networking session, so feel free to hang around and discuss with some of the industry professionals around, and I'm sure the students will definitely willing to do that. So thank you, and I'll hand it over to Diego.
Okay, this is me. My name is Diego Lamacchia, originally from Argentina. Lived in Brazil for about 6 years. I also been expat in Uruguay for another year. I've been in Australia. I worked also for a period of several months in Mexico, in Holland. I've been in Turkey, and pretty good time in Perth. Originally, I'm a pipeline engineer. I like to call myself a luxury plumber. And I started working in 1993, so I have about more than 20 years of experience. And basically, I work for 2 companies. Let's say 10 years with Intec Engineering, and 10 years with Technip Genesis. And basically, I can say myself that I'm an Intec engineer. You know, all those 10 years with Intec define me or what I am today. A big welcome to everyone. We call Abrazo de Gol, which is a goal hug for everyone. This is going to be we're going to try to participate. I mean, even this is a lecture. I can't do it quite prescriptive, but I'm not going to try to do that. So you guys have to participate. We'll do whatever we cover in an hour. Okay? We started at, what, 12:10. So by 1:10, we'll stop, wherever we are, and we go and eat. So let's make this kind of fun. And interrupt me whatever you want, anytime you want. I'm here also with Jose Gonzalez. Jose has been in the industry since its inception. and also can tell you guys during the presentation or even after during lunch good stories. I'm going to try to see an overall picture of what subsea engineering is. So I'd like to know how many in the audience we have that work for operators with several years of experience, operators or work in the industry. So raise your hand. You don't, okay. All right, and how many subsea engineering students we have? Okay, I raised my hand because I'm one of them. Actually, I was here until 11 o'clock last night, rising that riser project. At the end, it didn't run. But it's okay. I already figured it out. I had everything done, and at the end, I realized that I was putting things, I don't know what I was doing. It was 5 to 11, and my wife was sending me messages saying, where the heck are you, you know? So I need to go back and finish it up. The idea of this kind of lecture presentation, this is the table of contents I'm going to try to cover. We're going to go with a safety moment. We also include, in everything that we do, safety. We're going to take a little bit of subsea engineering. And then I'm going to try to show you guys, I mean, when I started 20 years ago, like I was one of you guys, I didn't have the picture. So after the, I have to say that I'm taking 2 classes. The other class is pipeline design, you know. And after the first test, I was in the parking garage, parking area, and then one of the my classmates, you know, we were talking about the test, and I mean I realized that he didn't have the picture of what was going on in the industry, I mean, he was thinking that engineering was done by FMC, was done by Cameron. So I said, well, you know, so I think, well, it's going to be good, you know, if we can, you know, stop by and tell you guys what the industry is about and how the pieces are together, so you can have the picture, and then you put it by yourself later on. So you don't have to go through all the stuff that I went through, you know, when I was your age. So we're gonna have the definitions. I want you guys to get out of here with the definition of what upstream and downstream is. To tell you the truth, I didn't know what that was until a couple of years ago. Why? Because I didn't care. Okay? It was not important. So obviously, if I think about it, you know, I knew about it. But when you have that concept right away and you talk about, you know, I didn't have that. We're going to be talking about what is onshore and offshore, and then we're going to talk about subsea. Then we're going to go with the operators, see how the operators take a look on that. And you will be moving. The idea is you put yourself around the whole industry, and you take a look. And you have to understand what the mindset of the other party is, so you can understand the way they think. So we're going to go with reservoir drilling and infrastructure. Some other people calling wells, drilling, and the facilities. And then I'm going to try to show you guys what is the difference between the field life cycle and the project life cycle. And with the engineering companies, subsea engineering companies, they look at that, the way they see that. During my two classes that I was taking here, you know, the teachers were showing that. But you know, we're shooting at different things, and actually what I'm going to try to bring here is the whole picture. So you make your own decision about what the life cycles are. And then we're going to talk about the different areas that we have: operators, drilling contractors, engineering and construction companies, suppliers, and then a little bit on subsea engineering. So you can, well, you know, let's go in the history. So we have Chaco here, you know, we have Jose. We can talk about, you know, a little bit of history of what pipeline engineering was, or actually subsea engineering. Subsea engineering started as I would say that it's 50 years ago as subsea pipelines, and then started adding other stuff. Have fun, ask questions. I don't mind, you know, any questions you have. Whatever we finish, if we do even 5 or 10 slides, I don't mind. There's going to be, maybe, you know, we don't cover whatever I said in the table of contents, but you will get here with something that you will learn. This is not prescriptive learning, it's interactive learning, what I'm trying to do. Safety moment, I'm going to go pretty quick. You know when a smell was put in natural gas? Do you guys know that? Anyone? Come on. Think. Do you know that gas was, had no, the gas that you take out from the production, from the well has no smell? Do you know that? Well, I'm pretty sure that some people didn't know that, that are here. So they put a smell, and you know why? Okay, but what caused it? It was London, Texas, New London, Texas, 1937. This is the high school before the explosion, and this after the explosion. The school was fueled by gas directly from the nearby oil wells. That means there was a leak. Nobody smelled it. It gets concentrated in certain areas, and then whatever, you know, whatever it gets ignited, and then you have an explosion. This is what happened. 300 people died. And from there on, you know, the Texas legislature, Congress, put the Texas Engineering Act, and PE certification is required since then. And actually, nobody can be called an engineer if he doesn't have a PE here in Texas. Do you know that? Okay. I can show you offshore accidents, the whole history later on if you want, but we're not going to keep going with safety. If you saw safety in that 69, Nothing. I mean, there was no safety at all. The job was done, and people were killed, okay? This is a typical subsea development. You know what that is? What project is that? It's there, come on, read it. What is that? Oh, I didn't say that, but for every question you respond, you get an extra ticket for the Genesis shirts, okay? The Genesis shirts are polo shirts. Let me show you that. Look, you know, if you play golf, okay, nice. I have one for the girls, one for the boys, all right? So because we have a gender diversity. So what is that? What is that thing floating there? It's called what? Semi. All right. What are those things here and here? They call what? Say it again. They are planes, but they have a bigger name because it's where the wells are drilled. So it's called what? Drill center. Who said that? Okay, we have an extra. So Nebulisa, you need to give him an extra ticket. All right. So we have the drill centers. There's two drill centers there next to Atlantis, and over the 6B escarpment, you have the DC3. And these are dual flow lines, steel catenary risers, pipe in pipe, 1,800 meters water depth, quite challenging job. Wells and manifolds. And these are the umbilicals. Subsea engineering. Again, another subsea project. You need to distinguish between, and then you will put it together later on, the subsea production systems, which are basically all the well tubing and completion, the subsea trees and controls, the manifold and jumpers, and the subsea processing and boosting. All that is part of the SPS. Actually, in the contracting strategies, many operators put that as a package. And it's called package number 4, SPS, Subsea Production Systems. Usually, their bidders are Cameron, Oceaneering, OneSubsea, Aker, etc., GE. And then you have the SURF. The SURF part is whatever is left, and includes the subsea systems again, you know, umbilicals, risers, and flow lines. That's what SURF means. Do you know that? SURF. They were very creative, you know, years ago about that, and actually they were trying to put the manifolds there in the SURF. But unfortunately, if they put the manifolds, what is going to happen is Smurf. And it wasn't look like, even though, you know, I would say that a few projects could be a Mickey Mouse project, could be a Smurf project, but you know, because everything happens, but it's not like that. So it's not a Smurf, it's SURF. And this is basically the little blocks that you will have on any subsea engineering company for everything that is underwater, and includes whatever you see here, which is the production part, and whatever you see here, which is the subsea intervention part, with the workovers. You have workover risers, etc., etc. For example, FMC does that, but they don't have drilling risers, for example. You put that? Okay, having said that, you guys gotta tell me what upstream and downstream is. Who knows what upstream is? Okay.
Upstream is all the exploration, production, extraction of the oil taken into the refinery, and downstream is when you take that carbohydrates and transform them into something different, something useful.
Okay, do you agree with that? Okay, so he said downstream and so we have 2 points here. So Nebulisa, he got 2 tickets. He didn't say not only upstream what a midstream is, and it's correct. Usually, the exploration, drilling, and production, and downstream refining, processing, and marketing is what that is. Okay? So the thing is, well, here is when you can see the net margins what the companies they do have. So more than 75% is in the upstream business. So that is what is important. And he said it's quite important. That's where he got 2 points or 2 tickets more. Is commonly known as exploration and production. Okay. Now, what is offshore and onshore? Offshore and onshore could be in the upstream business, because I can extract oil either from onshore or from offshore. Midstream usually is part of the downstream. Transportation, that type of thing is midstream, but usually we consider upstream and midstream. That's what you need to have in your minds. And the offshore industry is in the upstream side. That's where we are. It could be some exceptions, okay? Somebody knows an exception of what the offshore, well, that would be kind of 5 points, but think about it. Could be exceptions. Everything that I'm saying it's general, it's in the most general case, but could be different, could be something different. So this is where Subsea is. Subsea is where? Exactly. It's underwater, guys. So that is a point for her. All right? So you give that to her, Nebulisa. And it's part of the offshore industry. I know that sounds dummy, but you know how many people think about offshore and onshore, and they forget about what Subsea is. And then you have the offshore drilling, the subsea equipment, you know, offshore production, transmission and storage, gas and processing as part of the onshore. Onshore drilling is part of onshore. So people get confused about what is onshore and offshore, and then since upstream, onshore and offshore is in the upstream business, they confuse, and they always think that onshore is downstream. It's downstream. There's a typical mistake that people do. Okay. And this is offshore and subsea. Again, you know, we're going a little bit farther on this, and this shows the subsea engineering overall scope of work. Actually, it's a technique selling picture, but it shows the onshore, shows the offshore, and everything that is underwater is subsea. So onshore, offshore, and here is what subsea is. This is another typical. What is this development? This that is Tuttle Mariner development. It's North Sea. So we're going a little bit farther down. So we're showing what we have under the seabed. And what is showing there? The reservoir, great. What else?
Where the oil is.
The reservoir. What else?
Wells.
The wells, yeah. This is what? This is called, what is called? A wellhead platform. So the drilling is being done here. Here you have the drilling rig. So it's been down here. And you have, it's a directional or a vertical well? Directional well. Okay? So I said that. I said reservoirs and wells. What else do we have? Hmm? Yeah, we have a FPSO, some loading facility. Okay? That is part of what? Of the infrastructure that we have there. It's called also facilities. And the other one is drilling. So these are the three parts that you need to remember. These are the way the operators see, or they get a structure with. Is you have reservoir people, you have facilities people, and you have drilling. Usually the drilling, obviously they don't own the assets. The assets are the vessels, and they subcontract that. They get a drilling contractor to do that, but they need to supervise the drilling contractor. And they have specialized drilling people there. Why? Because it takes a lot of the money that they're going to need to do this development. And this is what is called an asset for them. So they divide, they acquire data, they define the different assets that they are going to develop, and they go into reservoirs and well, drilling and infrastructure. And they do that step by step. They start for the reservoir, they define where the wells are going to be, they drill a well cut, or an exploration well, exploratory well, appraisal well. They limit, the reservoirs, and they estimate the production profile of that reservoir. That is called the first reserves, or I don't know, I don't remember, it's proven or expected reserves. So there are different, it's 1P, 2P, and 3P reserves. So they keep going with more, so they do that part of the engineering of the reservoirs and well engineering, and then they keep going, they get a drilling contractor, they do an appraisal well, and they keep going, and then they start looking at the infrastructure. So when they are finishing up, or in the middle of the reservoir and well process, they start with the production side, with the infrastructure, the facilities. They start that process on the facilities. So subsea engineering, most of the time, sees the infrastructure part. And many times you need to see the picture that the guy, the operator, is looking at not only the drilling, but also the reservoirs and the wells. And then you start doing your conceptual engineering for the production system that you're going to define for your subsea development. And then you do different engineering phases, and right in the second phase, maybe in the select phase, they're going to do more drilling, and they're going to delimit the whole well, the whole reservoir. And they're going to have proven reserves, and they're going to have a production profile. Of that production profile, they're going to go and start doing the FEED phase, or the definition phase. Okay? And everything that I'm saying, we're going to see in the next slides. And basically, we're going to respond all these questions. You can also take a look and respond what, when, why, who, and how. Okay? So in subsea engineering, what we do, what we try to do with subsea engineering, what is the goal? Say it again? Okay, and yeah, that's basically what it is to extract the oil from underwater and basically develop or carry out with a subsea development, develop the subsea asset, so that we have an extra point there, okay? So when is done? When and why? This is common sense, guys. When and why? Yeah, who said profitability? Okay, another point there. So it's profit. When? Who cares? It's when they decided to do it. Who decided to do that? We'll say that it's the operator. But it's when and why is them. So, and it's profit. But we're not here just to say what, when, and why. What is, we already showed that. When and why, it's what they decide. But what I'm most interested is how and who. And by the way, this is subsea development that is Total Dahlia, by Technique, West Africa. So, how the thing is done, we're going to talk about what is called the field life cycle and the FEL process, or the project life cycle, which follows the FEL process. You know what FEL is? For 1 point, come on. So let's say 2 points. FEL. I'm not moving. You're really looking at that. FEL. What's FEL is? Nope.
Front-end loading.
Who said that? Oh, okay. Okay. We're going to give it a point. We're going to give it a point. We don't discriminate, you know. I don't have preconcepts. It's front, yeah, let's keep moving. Okay, front-end loading. Front-end loading. We're going to see what that is. And the operators, I said that, who are the ones? I already showed you that. So I want you to tell me. Who? By whom the Subsea development project is done? Who does it? So we have oil services companies. No, we don't call it that in the oil services company. We call it a little bit different. So we have first what? What is the big boy here? What? National oil companies, NOC. Okay, they talk that. But there is another name, and I'll help you out, is IOC, which is International Oil Companies. And those two are called what? Operators. Okay, so we have a point here. And then who else? Who else we have in the service companies? Okay, the one that provides services. And they call, how they called? How they are called? Hmm? They are contractors, yeah. They are called contractors. Everybody's a contractor. What else? Hmm? Engineering contractors, yeah. Those are, we're going to call it engineering and construction contractors. Okay, that's one, that's two, okay. Who else? Look, I don't even remember now. There are 5, I think. But it's okay. What else? Think about infrastructure, drilling, and reservoir. That's the way it is defined. So what we have? We have operators, we have engineering and construction companies. Who else? Hmm? The EPC are the engineering and construction companies. Engineering, procurement, and construction. EPCI, engineering, procurement, construction, and installation. Usually, and there's a big difference between the two. There's EPC and EPCI, and we can talk about, ask me that question later on. When we talk about engineering contractors. What else? What? Say it again? What is that? Exploration and production are the operators. And usually the exploration and production is the way the operators are organized. They have the upstream, exploration and production, and the downstream. And usually you have different business units all around. And you usually will deal with the engineering and the guys that are working for the upstream, the engineering and production business units. What else? Come on. One more and I'll show you all.
Drilling contractors.
Drilling contractors. That's great. Drilling contractors. We are drilling and they are drilling contractors. They get a big chunk. They have the assets, have those massive assets. So, and they get paid a lot of money because of that. So we have 3 and we have 2 more. Drilling contractors, they do the drilling. Operators, international oil companies and national oil companies, They also are the owners, and if they hire a consultant, you are also called the owner engineer for them. Oilfield services providers, those are the big ones. It's Lamacchia, Halliburton, Baker and Hughes. You know, they provide services. And usually they provide services to the reservoir and the drilling operations, but they don't do drilling. Okay? They service the drilling operators, the drilling operations, and the reservoir analysis, the reservoir engineering, and the well engineering. Drilling contractors, engineering and construction contractors, they do the SURF infrastructure, and the subsea equipment suppliers, they usually do the SPS, and they're also part of the infrastructure. So this is basically the whole picture. And we're going to go over each of you in more detail. I'm going to start with those first. Let's go with the how. This is the way the life cycle is seen by an operator. Acquire, discover, appraise, develop, operate, and divest. Acquire a prospect, so purchase of lease. Discover the reservoir. Appraise the reservoir with that wheel-cut well or appraisal well. Develop the concept. You have different stages there of engineering. Operate the asset. And abandon the facility. So those are the way the operator sees that. And each operator has his own field development cycle. And this is when it comes to the interesting thing that you're not going to see everywhere else. This is the way different operators see this life cycle. BP, Total, Chevron, this is British Gas, Shell, and obviously Pemex. I'm working with Pemex a lot. Different names, same thing. All right? So they're going to start talking about the phases of the project, of the project life cycle, and you're going to get confused. See what they're talking about. This talking about this. So you need to have the mindset of the operator and see what they are. If not, asking that question. Just to get this from BP, I got it 2008, and by luck, you know, it was somebody else had it in the wall of his office. And I said, hey, this is great. This gives me the picture. So I'm giving you this so you can see, you know, how different people see that. Usually, I saw this, you know, after 15 years in this industry. Let's go now on what is field life cycle versus the project life cycle. These names here could be different, but always, you know, they talk about the same thing. And there's two things that you have where you have the operating, the CAPEX of the, what is CAPEX? Capital expenditure, right. So it's the actual what? It's the actual money that we need to invest in order to get it. And from there, we have different phases, which is evaluate, select, define, and execute. The field life cycle and the project life cycle, which is the CAPEX, the project life cycle is associated with the engineering. Okay? Even though in the field life cycle you can do whatever engineering you want. There are different engineers that you can do, engineering work. But the subsea engineering companies, or the engineering companies that are doing subsea projects, they get into the CAPEX project life, and they do the different phases of the engineering. And here is why, you know, in some of the teachers here at school, they were showing the project life cycle, and they were mixing the words with the field life cycle. So I want you to get the picture of one is one and what is the other one. Evaluate and select is what is called pre-FEED, field development planning. Preliminary engineering. You know what FEED is? What is FEED? Front-end engineering and design, okay? And this is basically, well, that's the design. I talk about that is the FEED, the define phase, definition phase. And the execution is detail engineering. Yeah. detail engineering, fabrication, etc. During the execution, you do the detail engineering, and you also do the fabrication and installation of your asset, of your infrastructure. And there are different milestones there. One is the design basis. You need to start a FEED with a design basis. If you don't have a design basis, it's not called a FEED. And a FEED has only one option. You start doing the engineering, and you have different options that you evaluate. You start doing with a pre-FEED or an appraisal. You do kind of field development type of stage, whatever your phase the operator has. And then you have different alternatives. Usually the operator defines 200 alternatives that defines what is the most economical, the optimum development, and actually has 3 or 4 that you analyze during pre-FEED, preliminary engineering, and at the end of pre-FEED you come up with one. And that is one that you're going to select in FEED. A FEED only has one option to analyze. Is that the reality? No. You know, we can have 2, 3, whatever, and then we're doing FEED. If the operator wants to spend the money that way, it's okay, we'll do it. You know, but strictly from the conceptual point of view, a FEED starts with, you know, one option, which is the final option that at the end of the FEED, we're going to have the final investment decision, or we'll have the approval for expenditure, AFE costs. 20 years ago it was called that. Now it's, what is it called? Final investment decision, which is when they get approval for the upper management to spend all the money in that subsea development. And that, at the end of the FEED, you have what is called the basic design. And in Latin America, basic design is FEED. Okay? And to me, when I studied in a school in Argentina, they told me that basic design was a conceptual design. Because it's so basic, you know, that to me was conceptual. That's what we learned. So here we were talking about basic design in Latin America, and they were talking about FEED. And the FEED started, what, 15 years ago. The word FEED didn't exist before the 80s. Jose, FEED?
No. It was basic engineering.
It was basic engineering. This is the total approach, how Total sees that. You're not going to see this many, many times. So you can see the field life cycle here, and this is the project life cycle, all right? And preliminary, conceptual, pre-project, basic, call for tender, detail engineering, construction, and here are the different phases. This is the mindset for the operators. This is the mindset for the subsea engineering companies, okay? It's the mindset. That doesn't mean that they do that. And I do this type of engineering. No, the engineering companies, they do engineering for whatever engineering they have to do in any phase. But you need to put yourself in the area that they are talking about so you understand the picture. So in general, this is the mindset for the operators, and this is the mindset for the engineering companies. Obviously, the operators have an advantage if you work for a contractor all your life over you because they have the picture, and you don't, okay? But that the point is just to show you from now on what the picture is, you can also understand, you know, the way they think. I like this one. This is the PEMEX approach. Same thing, exploration and production, and you have, you know, the base and the prospect, reservoir opportunities, pre-FEL, which is called pre-FEED, FEL, and you have FEL 1, FEL 2, and FEL 3. Visualize, which is conceptual. Pre-FEL is feasibility. They call also feasibility studies. Visualization or conceptual? No, visualization or it's not conceptual engineering. It also could be also feasibility studies. Conceptualize is concepts, but BP sees this as selection. So they call it different. So even PEMEX call conceptualize the selection phase that BP calls, so you get confused. So you think, you know, conceptualize this concept is conceptual, they call it visualized. And then define, everybody almost calls definition, define the feed phase. And then it goes with the wells and infrastructure, that is an EPCI company doing that. Okay? And then production and maintenance for during the production, and then abandon. And this is how the investments go. You know? So they go here, they do the wildcat, spend a lot of money, and then they keep drilling two or more wells just to delimit the field. They keep going, and then during construction they spend the big money. And then during operation, here up to here, what you have? CAPEX. And from there on, you have OPEX. Okay? So what is CAPEX and what is OPEX? You need now to understand what is what. This comes up to here, and during operation is operational expenditures. Okay? And these are the uncertainties, how they go. When you start, your uncertainty is quite high, and then you are developing whatever engineering you are doing or developing your project, your uncertainties and risks go down. That's the idea. And these are all the operational risks that usually are associated with the big assets that you have on the field. Whatever you have floating during a project, okay, is where you have the big operational risks. So here are drilling rigs floating on the sea, you know. What I'm doing with my finger here. Okay, where it is? Okay, this is usually I walk around and I have I don't do this from one point. I'm fixed here anyway. And then here is where you have all the vessels installing that, and then it's when you have the production, you know, floating actually producing. You have the operational rigs at the best. Got the picture so far? Okay, it's quite simple, but I think it's important. Okay, this is the way we see the stuff.
Greatest ambition was to fly. Then he tried.
Well, we don't have that. What about this? Oh, here.
How do you get this thing back on the ground?
Man, I'm gonna cry. Oh. Okay. So that was the sales speech. We keep going. We stop where we have to stop. If you want to continue, we continue. Okay? You tell me. This is quite simple. You know, the way any subsea engineering firm sees the project life cycles versus the engineering life cycle, and you have associated with each of the phases conceptual, pre-feed, feed, detailed design, operational support. And here is usually the months, the time that it takes for each of those. Conceptual engineering, 3 to 6 months. Pre-feed, 6 to 12 months. 6 to 24 define. Usually the operator says 3 months for the appraise, 4 months for the select, and 8 to 12 months for the define. You know, and they wanted everything for yesterday. So that's where it goes. But what is important is when you do engineering, and you need to get that in mind, is that whatever level of engineering you do is associated with a cost estimate, okay? Because that is, whatever phase in that cycle is, the operator wants to know how much it's going to cost those CAPEX. And this is the cost accuracy that you have for each of the, in the appraise is plus minus 50%, plus minus 30% on pre-feed, plus minus 15%, plus minus 5–10% in the detail engineering. I have another chart that shows how actually the standard goes with the cost estimates. But please, when you do engineering, situate yourself in the phase of the project. Because you're going to try to do everything up to the detail, it's no point if you are in an appraisal phase, all right? It has to be something like this. So your engineering has to be associated, you need to have time management in order to do your engineering according to what is required. So if I said, I want to have this done in 40 hours, well, it's an appraise, yeah, it's going to be fine. But if I'm going to do detail, maybe that thing takes a month and a half to do it, all right? So every engineering task is associated with a certain phase and a certain level of effort. You're going to find all the time engineers doing their calculations, and they don't want to let it go. No, it's not fine. It's got to be right. It's got to be. Hey, we're here plus minus 50% of the cost. The number that I want is like this, okay? I don't want you to waste your time doing anything else. So they need to let it go. So situate yourself when you do engineering according to the level of effort that you need to put, according with the phase that you are working on. Okay, let's go with who now. These are the national oil companies. National, and I tried to put as much as I could. If I didn't put some of them, you know, sorry for the operators that are here. And these are the big six. ConocoPhillips, obviously, you know, that's good. So a point for Diego here. And Total, Chevron, ExxonMobil, Shell, and BP. All right? This is how, for example, the market sees the operators, and this is we receive market analysis reports every time. This is from September, so you can see how the share of that operator is doing. So how the perception of the analyst is. And unfortunately, you know, all this industry, since everybody has a share or is in the New York stock market, those guys, they tell you, oh, my perception is that, you know, Shell is doing quite bad, and it's going to happen, and they, you know, spread a rumor or something that, and those are guys that are maybe 22, 23, 24 years old guys, brilliant guys, but they haven't worked in this industry at all, but they see the numbers, and it's amazing how they decide, you know, a lot of things, what is going on in the market, and the share of these companies. These are the offshore drilling. This is the next part. That is a drilling ship. Basically, the offshore drilling companies, they own the assets, the drilling assets. The assets are the stuff that is floating. So it could be a drilling ship, a jackup, or a semi. And these are the big, you know, I put as much as I could, you know, but it could be, there's maybe thousands of these companies. No, not thousands, no, hundreds. So, Transocean, you know, well known for Macondo, and Saipem is also doing drilling, for example. Okay, the offshore engineering and construction contractors in the subsea market are all that. You have high technological assets and worldwide operators, like Saipem, Technip, Subsea 7, Herema, McDermott, and All-Seas, and regional operators, Petrofac, Seona, Schreiber, Clough. And usually Petrofac and Seona are entering into the market right now with new vessels. This is the Seona, the Schreiber vessel that you have here, the PS 5000, I think. Actually can do reel and S-lay. And you have different spools that you can put. You know, you get a vessel on the side, and you put your spools on your deck, and they can reel from there, which you don't have to spool on shore. You can spool, you know, while you are on the water. You go there and you put it. So they're trying to do it right now. You can search it out on the web. There's a lot of stuff regarding that. These are the big three. The most important one, Technip, Saipem, and Subsea 7. And this is the Petrofac new vessel that it can do J-lay because of the tower here, and also S-lay. This is from 2010. It's quite old, but it's where, you know, these companies are located, the high technological assets and the worldwide operations. And actually, this didn't come from Technip, it comes from Secon. Secon is a company in the North Sea. And you have a Subsea here. A Subsea does exist. Is a Subsea in the market? Who knows that? Well, Subsea is not in the market anymore. In 2011, it was merged with Subsea 7 bought it. Global is not in the market anymore. In 2011, Technip bought it. And now we have alliances with Technip and Herema. Usually Saipem and Subsea 7 could be together in some bids, and All Seas with McDermott also can be there. These are the engineering and project management companies. In parentheses, you have the number of people that they have. They do engineering and construction. You can do EPC or EPCI. If you do EPCI, they install stuff, their installation. Engineering, procurement, construction, and installation. If they say I, that means they have assets to install. Assets means vessels that float, that install the stuff that goes underwater. So the EPCI companies are basically these ones, and the engineering and construction companies, they do that, but also could be EPC, which are working not only on the offshore market with the assets, but also in the onshore market with all the gas plants, engineering, et cetera, that you have. Those are big engineering companies. The concept of engineering between onshore and offshore is different. We can discuss it during lunch. The way they work is slightly different. And here you have Technip, Saipem, CBI, Worley Parsons, Good Group, Bechtel, KBR, Fluor, Jacobs, Amec Foster Wheeler, Petrofac, Chiyoda. Also you have Chiyoda and the Japan gas company, JGC. Those are Japanese companies. Okay, Petrofac, etc. Now, these are the subsea engineering companies. And this is good for you to have. Good Kenny, Genesis, Intexi, Pespen, Jodus, Doris Engineering. Those are the most important. I say most important. Everybody is important. I say the number of people you have there is in parentheses. So Good Kenny has 2,500 people. Genesis is only 1,500. That means that one is better than the other one? No. Nothing is better or worse, guys. Everything is different. So we all do this. I wouldn't say the same thing. I would say differently, but anyhow, we all do good. And just for you guys to have an idea, these are the big three. All right. And this is a little bit of a story, how the subsea engineering companies came. And this is where Jose is going to help me out with a bunch of questions here. So, maybe Chapco, can help me out too. This is the subsea engineering companies, started with subsea pipelines, and basically was. I have to say, you need to have this name, R.G. Brown. R.G. Brown was the company that started this business. But the R.G. Brown people were somewhere else, and were in Bechtel. So I didn't put Bechtel as the start of the subsea. I think R.G. Brown was. So R.G. Brown went to Holland to open the business there, and maybe built a new vessel for the Russians, I think. Maybe Jose will correct me. And they opened an office over there. They hired a few people. Jose was employee number 3 or 7? 7 of that company. George Himko was the other partner that opened that office with R.G. Brown. And they hired several figures that they were very well known in the industry later on. And it was started with the pipeline business. And we had J.P. Kenny, or John Kenny. He didn't want J.P. Kenny, it was John Kenny. John Patrick Kennedy. He was hired by R.G. Brown. And then Andrew Palmer was also hired by R.G. Brown. J.P. Kenny was in London, was trying to develop work for Archie Brown. And I think the story is that he was doing all his work up to noon, and he has his free afternoons. So he tried to convince George Hinkle to do business in England, and he said, no, we're not going to do anything over there. So he finally said, okay, I'll do it myself. So that's, and he put his own company. It was quite funny because a year later, you know, the UK government opened the doors to all foreign companies tax-free for 10 years. And George Hinkle didn't want to do anything there. Anyhow, Andrew Palmer got there. He got, he also went out from the company and formed his own company. It was Andrew Palmer and Associates in '87. From J.P. Kenny got his company in '78. And there was an engineering manager from the Houston office, William Timmermans, who, with other 3 partners, formed Intec Engineering. And Timmermans was the guy who hired me at Intec Engineering 22 years ago. And when Intec Engineering were, at that time, 33 people. And today it's about 1,000 people. When I left, we were about 600. And I remember that when I talked to him, he spoke several languages. So I said, I want to become a real engineer. Yo quiero ser un ingeniero de verdad. That's what I said to him. And he gave me the job. He didn't have to give me the job. He didn't have to give me the job, anything. There were nothing. There were not a lot of work there. And I struggled quite much for 3 or 4, I would say 2 to 3 years, until, you know, I was able to, in English, say no and justify it. Because before that, I was, okay, yeah, okay, what the heck was that? And actually, a good story was that my first project was a mechanical span support. And the guys from Stena were there explaining what we needed to do for this pipeline mechanical span support. And I didn't know pipe, I knew what it was. Support, soporte, easy. Mechanical, mechanical, easy. Span, no clue. No clue at all. So what I did is, after the meeting, I saw what I had to do. I said, what the heck, I have to do that. So I went to the dictionary, say span, loose. Loose of the beam, you know, basically, you know, this space between the 2 supports in the beam. I said, wow, got it. 3 months later, the span support was ready and was built. Actually, no, yeah, they built it, but I didn't see how they built it. So I had the opportunity, I think 15 years later or 14 years later, to do my own project with the engineering manager and build it and install it. I was there and installed it. So anyhow, so that's kind of the history of the engineering firms there. And then Mentor Subsea was also built, opened in '87. Bestpen brought Andrew Palmer in '96. And then there were a couple of things that happened in the industry that all the installation contractors were buying engineering companies. So Herema bought Intec. McDermott bought Mentor. And Technip bought Archie Brown. Actually, Archie Brown, how many times sold the company? 4. He makes a lot of money. Actually, he sold it for 3 or for 10 or whatever and bought it for 1. So, yeah. And so that thing came up later, and were engineering contractors and engineering companies having their own arm of engineering, and they were doing EPCI projects, okay? So there was no issues with conflict of interest or anything like that. And back in 2006, Halliburton, who bought Kellogg and did KBR, did a project in Brazil, Barracuda Caratinga, and they lost a lot of money. So they went out of the market and said, no, this is not good for us anymore. McDermott did also another job in the Far East, I don't know, and they also lost a lot of money, so they get out of that EPCI business. And I recall reading an article in the Offshore magazine, which is the only one that I recommend you to read. There's tons of other readings, but the Offshore magazine is the best that you guys can read every time, about how Technip was the only one who could do, with an engineering company, EPCI projects without losing money. There was a nice article in the Offshore magazine saying that the others, you know, they play soccer, and we play football. So that was fantastic, meaning, you know, we know what we're doing. So, and then what else here? Then a good group bought MCS, JP Kenyon Mustang in 2009. That's why they have the good group. And MCS is a riser engineering company that started in the late 90s. Worley bought Intec C in 2006. I think C, they bought C and they put Intec C and they bought the Subsea and the floaters. C were doing the floaters, so they put everything together. And Halliburton bought KBR, and I saw the story there. They later on take it out, and KBR is by himself. This is quite important on the oil service providers. Nobody's telling me anything about the time. So we're 4 minutes above. You want to keep going, or you want to finish here? Okay. So let's try to do maybe 10, 15 more minutes or whatever. These are the companies that we have, the oil service providers. You have the amount of revenues that they do per year. B is billion, okay? Just for you to know. And then you have 126,000 people. Actually, I don't know why I left the word people, basically. Oh, anyway, mistake. And then you have, 10,000, 3,000 people. And I put several of those. And you can see that nowadays, Halliburton bought Baker and Hughes. Is that right? Or they are trying to. Actually, put $3.5 billion just as a security. If the deal doesn't go with the antitrust thing, they can lose that. So if they put $3.5 billion, they are sure that they're going to get the merge. Weatherford, BC Services, I'm going to talk about CGC, which is basically the company. I put CGG because it was the company they do seismic, and they were founded in 1930-31 by Lamacchia in France. And Lamacchia later on left it and put his own company. And now actually Technip put yesterday an offer for $2 billion to buy it. Okay, these are the subsea equipment suppliers. In parentheses, you see the number of people that they have. Aker Solutions, what Aker Solutions? Well, as a service provider, they can do trees, manifolds, umbilicals. So as the SPS, they usually do not do the installation, or maybe they subcontract a vessel to do the installation. Oceaneering, they do umbilicals. Umbilicals, because I know, maybe I'm saying something that is wrong, because they know what they're doing, the whole scope of work. But I'm talking about perceptions. Oceaneering, they're pretty good in ROVs and umbilicals. Siemens is a big corporation. It's over 400,000 people, but they do refrigerators also, So, but they have the oil and gas division, and they are also pretty good in automation. Oil states industries, for example, they are pretty good in forgings, specific forgings. They know that for example, flake joints, etc. GE Energy, also they do a lot of stuff, but they have an oil and gas division. FMC, I know pretty because of the trees. Cameron, also for the trees. And what the industry is going, well, there are others. I put there several others. In the top, you have all the stuff that I do, geotechnical surveys and geophysical surveys. Wasco, Socoterm are coating companies. Balmoral and Trelleborg are floating buoyancy. Tenaris and Chorus are pipe. T.D. Williamson is pipe inspection. This is what is kind of nice to discuss. What is happening? How the alliances are? The price of the oil is going down nowadays, and they are trying to put the pieces together. So now it's time to to shrink, not get a lot of people off, but shrink, put the synergies in place and redistribute the picture so we can have in a better position to fight basically against the reduction of the oil price at 80. At $80, we have this strategy. At $100, we have a different strategy. So, Technip and Genesis started an association that comes with R.G. Brown. And basically, the deepwater engineering division of Genesis were incorporated with Genesis Oil and Gas in London, and they formed Genesis. And Genesis is a company from Technip. KW bought, Petrofac bought KW. Petrofac is a big construction and engineering company, but they do a lot of well engineering. Well engineering. And they have KW. And Saipem and Chiyoda are together, and offshore, onshore, big engineering contractors. And they got Exodus Subsea now. That was a couple of months ago, because the Exodus is trying to be one of the fourth, or the fourth in the picture of the three. And then, and this is what is quite funny, what is quite interesting, with the oil field services providers and the subsea equipment providers. They started, getting the subsea equipment providers. They started getting alliances with subsea. So with pump providers, because subsea boosting is seen as a key in the future. Why? Because everything is decreasing, and those wells, those reservoirs are being marginal fields, and they need to pump it up, they need to suck it a little bit more, so they are trying to do subsea boosting pumps. So everything that is related to pumps, the subsea equipment companies, they start getting associated with the pump suppliers. So we have Cameron and Framo, we have FMC and Sulzer, and we have GE with Lufkin and Dresser. Those are already in place. But they went ahead a couple of years ago, these big companies, the oil service providers, getting an alliance with them. And then we have Schlumberger with Cameron, which forms one subsea. And then Baker and Hughes with Aker Solutions, which form the Subsea Production Alliance. And FMC and Sulzer, I don't know what it's going to be. Maybe it's Halliburton? I don't know. But Halliburton already put a bid here. They're going to be with them. So where's FMC going to be? I don't know. And then GE, they are talking about National Oil Varco, another one. So it's changing. These are what is future developments. Arctic marginal fields, subsea pumps, alliances. Mexico deep water, ultra deep water, those are the areas. Mega developments in West Africa, gas discoveries in Tanzania and Mozambique. Prosperidade, it's a massive subsea field in Mozambique. It's Mozambique, sorry. And yes.
What's a mega development?
A mega development. Mega development, it means multi-million dollars, means billions of dollars. Okay, it's called more than 300. Somebody called mega. I call a mega project more than 1,000 million, 1 billion. It's billions. And we have, in China, we are developing now from shallow to deep. We are going the way we were doing in the Gulf 10 years ago. Pre-salt in Brazil. And there's a lot of floating LNG. And the floating LNG is basically the LNG plant squeezed in a boat floating. And that is upstream or downstream? Huh? What is a floating LNG? Upstream or downstream? Who said that? All right, we have a point there for the, yeah, it's both. They're putting everything together. The plant that is it's right at the verge, but I would say that it's a lot of upstream, but it has a little bit of downstream, so it's both. And even the it's putting down the transportation. I mean, if I had to transport thousands of kilometers, from the States to China, if I got to put it through a pipeline, no, I put it through a vessel floating, and then I carry that with vessels. So the cost there, and those are massive, massive projects. And we are competing against shale gas. So that's why the price went down. Okay? So we have a lot of oil now. And we are not going to be doing shale. I mean, with subsea engineering, we work on the other ones. That's right. So deep water technical challenges that we face in the future. I like the teacher, the subsea pipeline gas, they call it about the challenges. It's challenges for everywhere. So we're talking about deep water. So we're going to be more than 3,000 meters. We're going to be farther out, harsher environments. Dispersed reservoirs, we have high pressure, high temperature conditions, heavier reservoirs, sour, typical Ayat Seal, Gulf of Mexico, deep water and sour oil. Flow assurance issues and more complex top size and regulations. And you can see a picture of the Prelude floating LNG with a picture from the London line. Look at that, it's massive. And what is deep water and shallow water? When I started, 300 meters was deep water. Okay? Chaco, when you started, what was deep water?
Nothing was deep water.
Yeah, nothing but sea was deep water. Okay? What's going to be in 20 years? I copy and pasted from Chris Tam's presentation. It's in the web anyhow. I like it. I know Chris. I hope he doesn't mind showing this to you guys. And this is what is happening, This is where we're going. I don't know, maybe, look at this guy in the sky, working with that. I don't know where we're going, but it's going to be, it's not like 20 years ago, People try to do a lot of abacus now, a lot of analysis. We need to think about good engineering judgment also. Quiz. Oh, we're at the end. So, the question is, what is offshore? What is subsea? And what is onshore? What is that thing here? And what is that thing here in the middle? What is this? And what is this here? Who said wind farm? Okay, a point there. And there, what is this? Huh? FPSO. Something else. No. What is that? Who said that? FLNG. Chaco? A point for Chaco. Okay. So, subsea, offshore, and this is the wind farm. This is onshore. This is offshore. This is subsea, and this is the floating LNG. And this is the pool base. Okay. Go to the Subsea Oil and Gas Directory now and take a look on that with all the stuff that we said today and see, if you are going to be able to break it down much better than yesterday. If you can do that, I will be more than happy, and this lecture, or whatever you want to call it, it was appropriate. That's all.